The perimeter of a triangle is 47 inches, okay? So 47 needs to be circle. The second side is 6 inches longer, so we have 3 sides because it's a triangle, correct? So that would be side 1, 2, and 3. All right, so what I'm going to do is I'm going to go ahead and organize my thinking and write down 1, 2, and 3. The first thing that I need to do is figure out which one of those 3 sides I do not have info for, okay? So the second side is, I have info for the second one. Says the third side is, I have info for the third one. So my x would be 1. Okay, now I'm going to go back and translate what side 2 is. Side 2 is 6 inches longer. It should be then the first, it should be then, and that's your backward way, right? So whatever you have after, you got to write first. What's after? The first side, and what's the first side? X. Longer than means addition or subtraction? Addition, and how many are you adding? 6. There you go. The third side is 1 inch longer than twice the first side. So whatever goes after then, you got to write first. What's twice the first side? 2x. And if it's longer, 2b plus, and that would be 1. Now when you add it all up, because that's what perimeter is, it should be equal to what? To 47, okay? So let's see if I can add something up over here. I can do the x's and I can do the numbers, right? So that'll be 2, 3, and 4x plus 7 equals 47. After that, calculator takes over if you want to do it with a calculator, right? How would you do it on equation solver? 4x plus 7 minus 47. What does x equal to? Okay, 10. Now, on that test, 10 will be an option. It will probably be first. You will read it first, right? And the correct answer is. So always go back to your question and see. How long is the, am I asking for x? No, I'm sure not. Okay, 10 will be option A or B, and the correct answer will be on option C or D. So be careful, because if you got 10, you know how to do this. Okay, so the only thing that I'm supposed to do right now is plug it in, and that would be equal to 21. Okay, so this would be A or B, this would be on C or D. Don't let it get you. And 2 more Fridays, all right? All right, there's 76 jelly beans in the bag. So that's the total, correct? Total will be 76. There are 20 fewer purple ones than red ones. So I already know that I have purple ones and I have red ones. So I'm going to put a P and an R for purple and red. There are 30 more yellow ones than red ones. So I also have yellow ones, okay? So as I'm reading, I'm organizing my data, okay? Yay? Do those strategies because that really helps out when you're doing word problems. All right, so I'm going to go back. There are 20 fewer purple ones than red ones, so that means I have information about purple. There are 30 more yellow ones than red ones. That means I have information about yellow, so which one is my X? Red. Red. Very good. Okay, so let's go back to the purple. 20 fewer purple ones than, that's your backward words. How many red ones do you have? X. Fewer ones means subtraction. And how many am I taking? 20. Very good. Now let's go to the yellows. There are 30 more yellow ones than red ones. So backward words, red ones would be X. More than would be add, and how many am I adding? 30. All right, so just like the perimeter, you're going to add the purple, the red, the yellow to have a total of 76 jelly beans, right? So let's see, 1, 2, and 3 X's. And then 30 and negative 20, 10. Very good. And that should be equal to 76. Okay, how would you write it on the calculator? 3x plus 10 minus 76. If you don't want to do it with a calculator, it should be minus 10 divided by 30. Okay, and you're going to do that to the 76. What does x equal to? How much? Okay, 22 will be probably A or B. I'm not sure that the problem is asking me for 22. So let's go back. How many? So is it asking me for 22? No. I'm going to have to plug it in, and the correct answer would be what? 52 jelly beans. I mean, yellow jelly beans. Okay? Remember that 22 will be an option, and we'll see it before the right answer. Keep doing here. Okay, don't let it get you. All right, find all values of x which make this equation true. So there's nothing I need to do over here, right? Because everything is inside that absolute value, right? All right, so all I'm going to have to do is move that to the front, correct? And then put a -4 in front of that inequality sign, right? So -4 greater than or equal to x minus 5 greater than or equal to 4. Okay, now I take the back, and I take the front, and I do my two inequalities. Is everybody with me? Yes? No? Yes? All right, so the first one would be -4 greater than or equal to x minus 5. And the second one, you cover the first, would be x minus 5 greater than or equal to 4. Okay, so now I'm going to take this one. It really is, it's not worth it doing it with a calculator, right? Because they're just so easy to do. So x is less than or equal to 1. Okay? So anything that doesn't have a positive 1, I can cross it out, can't I? Okay, so I don't think that has a positive 1. I don't think that has a positive 1. That one does. So those two are still contenders, right? With me? All right. Then the next one would be plus 5. Plus 5, x is greater than or equal to 9. So it has to be letter what? A. There you go. You do. All right? Yes? All right. Let's go and open our notebooks. Okay, start. That means you're quiet, correct? All right, a cost of school banquet is $95 plus $15 for each person attended. So let's try to figure out what is the independent variable and what is the dependent variable. Remember, the independent variable is the one that you change with a purpose, right? You change it on purpose. Which one is it? Say that again. People attending. Thank you so much. So the number of people attending. All right. What would be my dependent variable? The cost. Very good. Which means what's your x? As on me. What's your x? What is your x? Which is what? Which is the number of people. So this would be your x. And the cost would be your y. Okay, write an equation that gives the total cost as a function of the number of people attending. So y equals 15x plus 95. What does that 15x? What does the 15 represent? How much cost per person? And then how much does the 95? What does the 95 represent? No. What does the 95 represent? Jane. So I'm only going to spend $95? No, more than 95. So what is the $95? What does it represent? Say that again. The y-intercept. Thank you so much. The y-intercept. If my iPad was working, I would give you like 5 points. Thank you so much. The y-intercept. What is the y-intercept? Your starting point. Thank you very much. Your y-intercept is your y is your starting point. Thank you. I forgot what I was about to say. is your starting point, which means if there are no people attending the banquet, how much money do I still need to pay? $95, okay? Your y-intercept, x is always 0, all right? So identify the rate of change. What is the rate of change? $15. Very good. Identify your starting point. 95. And we're also going to call it my y-intercept. Very good. That's your starting point. Define the domain. One person raise your hand. What's my domain?
0.
Very good.
0.
Very good. Back of the table needs to stop talking, and he needs to stop talking now. Infinity, because technically, if it's a banquet and if it's held somewhere, it should have a limit, but it's not telling you what's the limit, so it's infinity. Very good. All right, somebody raise their hand and tell me what this range is. Would somebody want to do range? What would the range be, Mario?
Bracket 0.
So I don't pay anything? What's the range? The range is what? It's your y, correct? Come on, help him out. Very good. To infinity. Very good. Because it doesn't technically, it's not telling me what's the amount that I can put inside that wherever they're doing. Wherever they're doing the banquet, right? So technically it's infinity. Now, what is the cost of 77 people attending the banquet? What do you do right now? Samuel, what do you do? Very good. You're going to replace 77 for x because x is telling you before a thing and it's telling you that it's 77. Very good. So in that one, it would be 15 times 77 plus 95. Samuel, how much would that be? Samuel? How much? Okay. Help him out. 1,000? Drea? 1,000? 250? Yay? All righty. Let's go to the next one. We're done with that one. Now, we're going to go ahead and use the calculator to graph this equation. Okay? So we're going to open up our calculator. Trying to, clear the calculator. Every time you get the calculator, I need you to clear it, okay? So does anybody remember how to do that? Second plus 7, 1, and 2. Very good. Second plus 7, 1, and 2. Very good. Now, after you clear, I've already cleared mine. Where do you go to graph a function? To y equals 2. Very good. And let's write the function. The function was what? 15x plus 95. Right? Now, before I graph it, I'm going to go ahead and take a look at my window because this default window is only from -10 to +10 and from -10 to +10. Is that going to be enough to see my graph? What's your starting point in here? 95, which means your range. And this is where the domain and the range are really good for you to figure out what to set my window on, right? You told me that the domain was 0 to infinity, right? So do I really need to start on -10? No. I can start on -1. Or even in 0. It really doesn't matter, okay? Now, should I stop at 10?
No.
Probably not. Only 10 people are going to go to a sport banquet or some type of banquet. No, there's going to be a lot more, right? So let me go ahead and change that to, I don't know, 50, 60, 100. It really doesn't matter. As long as it's more than 10, something reasonable, right? Let's do 100. I'm going to keep it on a scale of 1 and might change it if it needs to. Now, you told me that the range was from 95 to infinity, right? So what would my minimum need to be? 0. So let's think about it. If it's 0. If it's 0, and I keep it over here at 0, right? That's the range. That means I'm not going to have any negative numbers. And you're right, I don't need any negative numbers on y, right? Because this is 1. I don't need any. What's my starting point? 95. So If this is 95, do I really need to start at 0? No. Okay, I don't. This is where common sense is really important, okay? Because you can graph it, but you might not see what you really want to see. So what would be a reasonable minimum Y? 60? That's a good one. Even 70, even 80. It's okay. Anything that's closer to what? To 95, that's not 95. Because if it's 95, then you're going to see it right there, and it's going to be a little bit hard to do. So let's do 60. That's fine with me. What about your maximum?
100,000.
77 people was 1,250.
200. 500.
Let's do 500. 500. It really doesn't matter. We just want to see the graph, right? Now, 500 might not be a good number. But we'll see when we graph it, right? And if we don't like it, we can always go back to the window and do what? And change it. It's not a really big deal. Okay, so let's go to the graph. There it is. You see it? Yay? I may want to make it smaller so that I can see really that graph over here. This bothers me over here. So that's your X maximum or X minimum? So let's go back and change my X maximum. I'm going to do 50 and see how it looks. See, the good thing about this is, there you go, that's a better number. I think that's better. So go back to the X and change that X maximum to 50, and that's a little bit better. Okay, so this is what I need you to do. I need you to go to your graph paper, and that first graph that you see, just sketch it. Just sketch it. You don't need points. Just how does it look, okay? We got it? How does it look? You can do this one with a pencil or with black coloring pencil or with one color. It really doesn't matter, but you need to label it. So how are you going to label it?
With the X's, color, and then the white and letter color.
So in here, right? I'm only using this, right? Only this one because I'm not using any of this. I don't have any negative numbers over here, right? So if you want to just sketch it, you're just sketching it. That's all you're doing. Correct?
Yes.
So it doesn't need to be perfect. It does not need to start in 0. Correct?
Yes.
So let's just put it over here. And then we're going to label it Y equals 15x plus 95. That's our first one. See, you just sketching what you're doing. It doesn't need to be correct. It does not need to start in 0. Make sure that you're using your X and your Y correctly. That paper should not be sideways. It should be up and down, right?
Yeah.
Should not be sideways. Should not be sideways. It should not be sideways. Because if you're doing it sideways, then you're not using your X and your Y correctly. It should not be sideways. All right, I'm going to say it again. The paper should not be like this. Correct? No. Yes. Got it? Because if you're doing it here, you're mixing the X and the Y. All right, are we good? Let's go back to the situation there. We both sketched that. It's not a big deal. Let's go back. Now we got to answer some questions. Okay. Okay, so use your calculator to graph the equation. Use the further equation to sketch and label the line. We've already done that. Is the data continuous or discrete? Really? You're going to have half of a person? Can we provide everything from last Friday? What do you need to take a look at when you are deciding if a graph is continuous or discrete? If it's real or... Where do you need to take a look?
Right there.
Your X or your X. And what is your X? The number of people. You cannot have half of a person. So this graph is not continuous. What is it? Discrete. It's discrete. So the back of that first page should be number 2, correct? The company decides to increase the flat fee charge to 125. Write an equation that gives the total cost as a function of the number of people attending. So now it's not 95, it's 125. So how would my equation change? Y equals plus 125. 25. Now it's not 95, it's 125. So what have you done to the flat fee? They have increased it or decreased it? They have increased it, right? That's important because we're going to figure out what happens to that graph in a minute now. Graph and sketch and label the new equation. Before you do it, what do you think is going to happen? How do you think it's going to look? How do you think it's going to look?
Steeper.
Steeper?
Longer.
So I'm hearing steeper, I'm hearing longer. Not sure what that means by longer. So what do you mean? What do you mean? So he said something very smart. He said the Y is going to be more off. He didn't say it grammatically correct, but he mathematically was correct. What do you mean by that? Where would you expect for that line to be? On top of that one or underneath that one? On top of that one. Why? How do you know that it will be on top of the line that you have right underneath? Because I increase what? So my intercept, which is also my starting point. So let's go ahead and write it. We're not going to take away the other one. So let's go to y equal to, and let's go to y2, and we're going to write 15x plus 125, and then we're going to graph. And just like Carlos said, that graph, that second line is what? Higher. So increasing the y-intercept does what to the graph? Shifts it what? It shifts it up. There we go. So increasing the y-intercept, stop talking, increases, shifts the graph up. I'm going to change that y equal to, is that okay, the y, the range over here? Because it's too big and I wanted to see them a little bit more separate. So let's go to the window. I'm going to change my y maximum. Let's do 250 and see how it looks, okay? Or you can do 200. That doesn't, it's still the same way. We need to do the scales differently. Let's go to 500, but let's do the scales differently. I'm going to do 500, but then on the scale, I'm going to do every 25. Is that cool? So instead of counting by one, it's just going to count by 25. Let's see what happens. Yes, just it didn't do anything to it, but it's okay. It'll be okay. All right. So now we're going to sketch it, and this is where you need to find another color, different color, and let's sketch it on the same spot. So where would it be? Higher, correct? Yes. It's going to be higher. It's going to be the same slope. So that doesn't change. So a different color, sketch it higher, and then label it y equals 15x plus 125. And let's write down what we just said about what happens to the graph when you increase the y-intercept. Okay, so if the y-intercept is higher, right? If I increase it, what's going to happen to the graph? It's going to shift up. It's going to shift up. What do you think is going to happen if I make the y-intercept less? If I increase it? Then it's going to shift what? So if the y-intercept is increased, it shifts up, but if the y-intercept is decreased, it shifts down. That's it. Okay? That's simple. That's all you need to do. Are we good? Yes? Can I go back to the problem? All right. Identify the rate of change. What is my rate of change in that new one? It's still 15. That hasn't changed. But what would be my starting point or my y-intercept? 125. Okay, has the domain changed?
Yes.
Domain. From what to what? From 0 to infinity. Remember, domain is the number of people attending, right? The range is how much it's costing. So has that changed?
Yes.
Yes, because now it doesn't start on 95. What does it start on? On 125 to positive infinity. And remember, only because the problem is not telling us a certain amount of people that can attend the banquet. Okay, so what is the cost of 70 people now? 77. So that would be 15 times 77 plus 125. So what do we got?
1,280.
And so the other one was 1,250, and this one's gonna be 1,280. Okay, so what type of transformation have occurred? How did we change it?
$30.
What did we do? It went from being this function, right?
Yes.
How did we change it?
We added.
Where y equals 15x plus. It went from being that, correct? To what? To y equals 15x plus 125. So what did we do to it?
You added 30.
Added how much?
30.
I added 30 to what?
The y-intercept.
To the y-intercept, which means I change it to f of x plus 30, right? Because what is f of x? 15x plus 95, okay? And what did I do to it? I added 30 to it. So it's like doing this, taking my f of x, which is, this was one of those movies that you needed to watch for the class, that f of x was the same thing as y, okay? So I took my 15x plus 95, because that's f of x, and I added 30. And when I added 30, I ended up with 15x plus 125, okay? So how did it look in the graph? It went what? It shifted? Very good. So that's a shift. We already have that on our graph paper, correct? Okay?
Yeah.
With me? Yes? All right. The company decides to keep the flat fee the same. So now we're going to keep that 95, but double what they will charge for each person attending the banquet. So now, the 95 stays the same, but what changes? I don't know, just check which one. So that needs to be page 3, right? This needs to be page 3, so number them. You don't have it?
It's behind our airplane.
Behind the, yeah? All right. So now the flat fee stays the same, so it's going to be plus 95. Okay? But then what changes? Instead of $15 per person, we're going to be how much? $30 per person. So how does that change the equation? 30x. Very good. You're welcome. Okay, so let's graph the equation, right? Let's go back to my calculator. And then I'm not going to delete any of them because I want to see how much they changed, correct? Let's go back to the window and change it to 1 because I really didn't like what we did on that one. Let's change it back to 1. I'm going to change this to 250 and change that y maximum to 250. Okay, so change it like I have it right now. That's the setback of a calculator. You're going to have to play with it, but I'd rather do that than graph like this. I really do. And once you get really an expert with this, it's good to go. All right, so I'm going to go back, now that I've changed that, right? I'm going to go back to my y equal to, and I'm not going to delete anything. I'm going to say 30x because I want to see how they look, right? Plus 95. So now the y-intercept is the same. I double the rate of change. You ready to see it? So what do you think is going to happen? Some of you already probably have seen it. What do you think is going to happen?
More vertical.
So it's steeper. Very good. More vertical. Very good. I like that. More vertical, steeper. Very good. Good job. So this should be steeper. That's the second one.
Yeah, it is.
And then that's the other one. You see it? You see it? Let's change the window. I don't like that window. Let's change maximum to...
It's because we changed the.
No, no, no. I put it back to 1. There you go. There it is. There it is. There it is. That's better. Okay, so this is the first one. That was my original. That one was 15x plus 95. If you want to see what I see, I just changed that x max to 20. Okay? I just changed it to 20. Negative 120. 160, 250. No, not 160. 1 and then 60. 250 and then 1 and 1. Just look at the board and make sure you have what I have. All right. All right, are we good? Okay. So I'm going to graph it again. I'm going to go to the graph again. So that first one was y equals 15x plus 95. And then that second one is 15x plus 125. Now, what do you notice about these two lines? They're perpendicular. What does perpendicular mean? No, perpendicular is making a cross. Exactly. So what are they? Parallel. And what did they have? What did those two lines have in common? Let's go back. Let's go back to our representation. Thank you. Say that again. The slope. Those two lines were parallel, like Yvette said, and they have the slope in common. Look, 15x, 15x. So what can you say about lines that have the same slope? The parallel, right? They will never ever touch. So parallel lines are or have lines that have the same slope. When we do systems of equations, that's really going to help you out. Okay? So let's catch the other one. Let's pick a different color. And then that one starts where? With the black or with mark blue? With the what? Somebody said it. With the black. I don't see any green values. What do you see the green? You see your green. Okay, gotcha. All right. So it starts with the black because it has the same y-intercept, but now the slope instead of 15 is what? 30. So that makes the line steeper or more vertical. There we go. So remember, we're just sketching. It really doesn't matter where you start. We're just sketching. Now we got to label it. Y equals 30x plus 95. Now, let's talk about what type of transformation happened over here. What happened over here? What did we change? The slope. We changed the rate of change, which is also called the slope. I love the vocabulary. Now, and then what did we do with the slope or the rate of change? How did we change it? We doubled it. We doubled it. It was 15. We multiplied it by 2. And what happened to the graph? It became steeper. So what do you think? If I increase the slope, what's going to happen to that graph? If I decrease the slope, what do you think is going to happen? Okay, so bigger slope, more vertical. Less slope, more horizontal. More horizontal. See what you guys have a highlight on my day? This is awesome. Okay, so identify the rate of change. What's the rate of change now? 30. $30 per person. Identify the y-intercept or next starting point. 95. Let's do the domain. Define the domain. Remember, domain is the amount of people, right? So what, Emily? You got it, you got it. Oh, come on, girl. Bracket 0. All the way to infinity, because it's not telling me that there's a limit to how many people can go to this banquet, right? What about the range? 95 to, very good. All right, what is the cause of 70 people going now? What do we do? Talk to me.
Change the X into
Okay,
77.
substitute the x for 77, so that would be 30 times 77 plus, no, you, 2,405? All right. It's double from what? From the, why do you think it doubled from the first one? How do you know? Because we what? Oh, very good. So what type of transformation has occurred, Armando? It's on their board. Yes, it's there. Can somebody please tell them how to pass it to the next one? All right, what type of transformation has occurred? Okay, so I double, I increase the slope or the unit rate, right? And what did it do to my graph?
Made it steeper.
Made it what? It means that it was steeper. More steep, right? Or steeper. Okay, so let's write it in function notation. It went from f of x to what? We didn't do plus. Times 2. Very good. So it went. Now, did I multiply everything by 2, or was it just the slope? Just the slope. Right? So just the slope. Because if I multiply everything, then it's going to change my y-intercept as well. Are we good?
Yes.
Yes?
Yes.
Can we move on to the next one? Yeah, your name. Okay, I see. Scare me now if you're still copying that. Okay? Is that all? Are we good? Okay. All right. I'm going to give you 5 minutes. You need to work on this one as a group. Let's go. 5 minutes. Go. All right. So the airplane is 30,000 feet above the ground. It's getting ready to land, so it starts descending at 2,000 feet per minute, right? Okay. So what's the equation? 30,000 equals. Not 200, right? But 2,000. All right. We're gonna write down and then we're gonna sketch because you're gonna have to change your window. Okay. So identify the rate of change. Negative 2,000. What about your starting point or your y-intercept? 30,000. Very good. Now it's continuous. Very good. Because there's half a minute. It's even 1/4 of a minute. There's even a fraction of a minute, right? There's even seconds in a minute. So yes, it's continuous. It's not discrete. Remember, you look at x to figure out, and your x would be your
Number of minutes.
number of minutes. That line should not go over there. I thought that was an independent variable because we did it on the other one, right? We had that independent variable. But it's continuous. You look at your x's. You're gonna have height over here, right? You're gonna have your height. You're gonna have your height over here and your time over here, right? And the airplane is descending, correct? Yes. Oh my God, already? Okay, well, let's stop. I'm sorry.